Welcome to Class 6 Social Science, Chapter, Locating Places on the Earth. In this comprehensive session, we will explore everything about maps, coordinates, and how we locate places on our planet. Let's begin our learning journey. Introduction to maps. Maps are essential tools that help us understand locations, navigate places, and visualize geographical features. They represent areas of land or sea showing physical features like mountains and rivers, political boundaries like countries and states, and human-made features like cities and roads. Without maps, it would be extremely difficult to plan journeys, understand geographical relationships between places, or study the patterns of our planet. Maps come in different types, including physical maps that show natural features, political maps that show boundaries, and thematic maps that focus on specific information like climate or population density. Types of maps. There are three main types of maps that serve different purposes. Physical maps display natural features of the Earth such as mountains, plateaus, plains, rivers, oceans, and other water bodies. These maps help us understand the physical landscape of an area. Political maps show human-created boundaries and features including international borders, state boundaries, districts, cities, towns, and transportation networks. Thematic maps focus on specific themes or subjects such as population distribution, rainfall patterns, mineral resources, or agricultural production. Each type of map uses different colors, symbols, and techniques to effectively communicate its specific information. Essential map components. Every map contains three essential components that make it readable and useful. Distance is represented through scale, which shows the relationship between measurements on the map and actual distances on the ground. For example, a scale of 1 centimeter equals 500 meters means that 1 centimeter on the map represents 500 meters in reality. Direction is indicated using cardinal points north, south, east, west, and intermediate directions northeast, southeast, southwest, northwest, usually with a north arrow. Symbols are standardized representations of features like roads, railways, buildings, temples, and water bodies. These symbols help convey maximum information in limited space while maintaining clarity and universal understanding. Understanding map scale. Map scale is a crucial concept that allows us to understand real distances from map measurements. Scale can be expressed in three ways: as a statement like 1 centimeter equals 1 kilometer, as a ratio like 1 to 100,000, or graphically using a scale bar. The scale determines how much detail can be shown. Large-scale maps show small areas with great detail, while small-scale maps show large areas with less detail. To calculate actual distance, we multiply the map measurement by the scale factor. For instance, if the scale is 2.5 centimeters equals 500 kilometers and we measure 4 centimeters between 2 points on the map, the actual distance would be 800 kilometers. Understanding scale helps us interpret maps accurately and make practical decisions about travel and planning. Cardinal directions. Cardinal directions form the fundamental system for orientation and navigation on maps and in the real world. The four main cardinal directions are north, south, east, and west. Between these lie the intermediate directions: northeast between north and east, southeast between south and east, southwest between south and west, and northwest between north and west. On most maps, north is shown at the top, east to the right, south at the bottom, and west to the left. This standardized orientation helps users quickly understand spatial relationships. Cardinal directions are essential for giving and following directions, reading maps, understanding wind patterns, and many aspects of daily life and navigation. Map symbols. Map symbols serve as a universal language that transcends linguistic barriers in cartography. These standardized graphical representations allow cartographers to convey complex geographical information efficiently in limited space. Different countries often have their own standardized symbol sets. In India, the Survey of India establishes these standards. Common symbols include blue lines for rivers, black lines for roads, parallel lines for railways, green areas for forests, and specific icons for buildings like schools, hospitals, and religious places. Colors also carry specific meanings. Blue for water bodies, green for vegetation, brown for mountains, and black or red for human-made features. Learning to read these symbols is like learning to read a new language that reveals the story of the landscape. Globes versus flat maps. While both globes and flat maps represent the Earth, they have distinct advantages and limitations due to their different forms. A globe is a three-dimensional spherical model of the Earth that accurately represents shapes, areas, distances, and directions without distortion because it maintains the true proportions of our planet. However, globes are not practical for detailed study of small areas and are difficult to carry. Flat maps are two-dimensional representations that can show large areas in detail and are portable, but they inevitably contain some distortion of shape, area, distance, or direction because it's mathematically impossible to perfectly represent a spherical surface on a flat plane. Different map projections attempt to minimize these distortions for specific purposes, but all flat maps compromise some accuracy for practicality. Latitude. Latitude is the geographic coordinate that specifies the north-south position of a point on the Earth's surface. It is measured in degrees, minutes, and seconds from the equator, which is designated as 0 degrees latitude. The latitude increases as you move toward the poles, reaching 90 degrees north at the North Pole and 90 degrees south at the South Pole. Lines of latitude, called parallels, run east-west and are parallel to each other. The equator is the longest parallel, while the other parallels become progressively shorter as they approach the poles. Latitude plays a crucial role in determining climate patterns, with regions near the equator low latitudes generally being warmer, and regions near the poles high latitudes being colder. The Tropic of Cancer at 23.5 degrees north and Tropic of Capricorn at 23.5 degrees south mark the northernmost and southernmost points where the sun can be directly overhead. Longitude. Longitude is the geographic coordinate that specifies the east-west position of a point on the Earth's surface. It is measured in degrees, minutes, and seconds from the prime meridian, which is designated as 0 degrees longitude and passes through Greenwich, England. Longitude increases to 180 degrees east and 180 degrees west, meeting at the opposite side of the Earth. Lines of longitude, called meridians, run from the North Pole to the South Pole and are farthest apart at the equator, converging at the poles. Unlike parallels of latitude, all meridians are equal in length. Longitude is fundamentally connected to time because the Earth rotates 360 degrees in 24 hours, meaning it rotates 15 degrees each hour. This relationship forms the basis for time zones around the world. Coordinate system. The geographic coordinate system uses latitude and longitude together to create a global grid that can precisely identify any location on Earth. This system works like the grid on a graph paper, with latitude providing the y-coordinate north-south position and longitude providing the x-coordinate east-west position. Any point can be uniquely identified by its coordinates. For example, Delhi is located at approximately 29 degrees north latitude and 77 degrees east longitude. Coordinates are usually written with latitude first, followed by longitude. This global addressing system is essential for navigation, mapping, GPS technology, and describing locations unambiguously. It allows us to precisely communicate locations for everything from emergency services to delivery services to scientific research. Prime meridian. The prime meridian at 0 degrees longitude serves as the fundamental reference point for measuring longitude worldwide. Established by international agreement in 1884, it passes through the Royal Observatory in Greenwich, England. Before this standardization, different countries used their own prime meridians passing through their capital cities or important astronomical observatories, which created confusion in navigation and mapping. The choice of Greenwich was influenced by Britain's naval power and the fact that many nautical charts already used it as a reference. The prime meridian divides the Earth into the eastern and western hemispheres and serves as the basis for Greenwich Mean Time (GMT), the reference for time zones worldwide. This standardization was a crucial step in global cooperation and accurate navigation. India's ancient meridian. Centuries before the Greenwich meridian was established, Indian astronomers had already developed their own sophisticated system of longitude measurement using Ujjayini, modern-day Ujjain, as their prime meridian. Known as the Madhya Rekha or middle line, this meridian passed through Ujjain, which was a renowned center for astronomy and mathematics in ancient India. Famous astronomers like Varahamihira, Brahmagupta, and Bhaskaracharya made significant astronomical calculations using this reference point around 1,500 years ago. Ujjain's location at approximately 75.8 degrees east longitude made it a natural choice as it was considered the center of the ancient Indian world. This early development of a coordinate system demonstrates the advanced state of Indian astronomy and mathematics long before similar systems were established in Europe. Time and longitude. The relationship between longitude and time is fundamental to understanding how time varies across the Earth. Since the Earth completes one full rotation of 360 degrees every 24 hours, it rotates 15 degrees of longitude each hour. 360 degrees divided by 24 hours equals 15 degrees per hour. This means that for every 15 degrees of longitude, there is a 1-hour time difference. Places to the east of any location experience sunrise earlier and therefore have later local time, while places to the west experience sunrise later and have earlier local time. This relationship explains why when it's noon in London, it's already evening in India. Before standardized time zones were established, each town used its own local time based on the sun's position, which created confusion, especially with the development of railways and telecommunications that connected distant places. Indian Standard Time. Indian Standard Time East is the uniform time observed throughout India, set at 5 hours and 30 minutes ahead of Greenwich Mean Time (GMT). East is based on the 82.5 degrees east longitude meridian, which passes through Mirzapur near Allahabad in Uttar Pradesh. This central location was chosen to minimize time variation across the country's extensive east-west span of about 30 degrees longitude, which would otherwise create a 2-hour time difference between India's eastern and western extremities. The adoption of a single standard time in 1905 simplified railway schedules, communication systems, and administrative functions across the country. Despite this standardization, there are ongoing discussions about implementing multiple time zones in India to better align with natural daylight patterns, particularly for northeastern states where the sun rises much earlier than in western India. Time zones. Time zones are regions that observe a uniform standard time for legal, commercial, and social purposes, organized to correspond approximately with lines of longitude. Ideally, each time zone spans 15 degrees of longitude, creating 24 zones around the world. However, in practice, time zone boundaries often follow national borders or regional boundaries rather than strict meridians to maintain time unity within countries or states. Large countries like Russia and the United States span multiple time zones. Russia has 11 time zones while the continental US has 4. The time in each zone is typically defined as an offset from Coordinated Universal Time (UTC), ranging from UTC 12 to UTC plus 14. Some regions also implement daylight saving time, adjusting clocks seasonally to make better use of daylight. This global timekeeping system enables coordinated activities across the world while respecting local solar time. International Dateline. The International Dateline (IDL) is an imaginary line on the Earth's surface located roughly along the 180 degrees meridian, exactly opposite the prime meridian. This line marks the place where each calendar day begins and where the date changes. When you cross the IDL traveling eastward, you subtract 1 day moving from today to yesterday, and when you cross it traveling westward, you add 1 day moving from today to tomorrow. The IDL doesn't follow the 180 degrees meridian exactly but zigzags to avoid splitting countries and island groups into 2 different days. For example, it bends eastward to include all of Siberia in Russia in the same day and westward to keep Hawaii and Aleutian Islands on the same side. This careful arrangement prevents confusion in daily life and business for people living in these regions while maintaining the global calendar system. Question 1. What is a map and how do we use it? What are its main components? A map is a representation or drawing of an area that helps us locate places and navigate. We use maps to find directions, understand geographical features, and plan routes. The main components of maps are distance shown by scale, direction shown by cardinal points, and symbols representing features. Question 2. What are coordinates? How can latitude and longitude be used to mark any location on the Earth? Coordinates are a pair of numbers, latitude and longitude, that specify the position of any point on Earth. Latitude and longitude together form a grid system. For example, Delhi is located at approximately 29 degrees north latitude and 77 degrees east longitude. This system allows us to pinpoint any location accurately. Question 3. How are local time and standard time related to longitude? Local time varies with longitude. For every 15 degrees of longitude, there is a 1-hour difference in local time. Standard time is the uniform time adopted by a country for convenience. In India, East is based on 82.5 degrees east longitude. This is why when it's 12 p.m. in London, GMT, it's 5:30 p.m. in India, East. Question 4. Using a map scale of 2.5 centimeters equals 500 kilometers, calculate the real distance from the estuary of the Narmada River to the estuary of the Ganga River if the map distance is 4 centimeters. Using the scale 2.5 centimeters equals 500 kilometers, we first find that 1 centimeter equals 200 kilometers. With a map distance of 4 centimeters between the estuaries, the real distance would be 4 times 200 equals 800 kilometers. Question 5. Why is it 5:30 p.m. in India when it is 12 p.m. or noon in London? This is because Indian Standard Time, East, is 5 hours 30 minutes ahead of Greenwich Mean Time, GMT. London follows GMT, which is based on the prime meridian at 0 degrees longitude. India's standard meridian is at 82.5 degrees east, which is 5.5 hours ahead of GMT. Question 6. Why do we need symbols and colors in the map? We need symbols and colors in maps because they help represent various features clearly in limited space. Symbols stand for different elements like roads, rivers, and buildings. Colors help distinguish between different types of features, blue for water bodies, green for vegetation, etc. This makes maps easier to read and understand. Question 7. Delhi's and Bengaluru's latitudes are 29 degrees north and 13 degrees north. Their longitudes are almost the same, 77 degrees east. How much will be the difference in local time between the two cities? Since both cities have almost the same longitude, 77 degrees east, there will be almost no difference in their local time. Local time depends on longitude, not latitude. Even though their latitudes are different, 29 degrees north versus 13 degrees north, this doesn't affect their local time. Question 8. Mark the following statements as true or false. All parallels of latitude have the same length. False, the equator is the longest parallel. The length of a meridian of longitude is half of that of the equator. True. The South Pole has a latitude of 90 degrees south. True. In Assam, the local time and the east are identical. False, Assam is east of 82.5 degrees east. Lines separating the time zones are identical with meridians of longitude. False, they follow country borders. The equator is also a parallel of latitude. True. Congratulations! You have completed the comprehensive chapter on locating places on the Earth. You've learned about maps, coordinates, time zones, and how to navigate our world. Thank you for learning with SilentReader and keep exploring our wonderful planet.